They look peaceful, majestic, dormant. But beneath their calm silhouette lies one of the most powerful and unpredictable forces on Earth. Volcanoes are not just mountains, they are windows into the Earth's fiery heart, a reminder that our planet is alive and breathing. Far beneath the crust we walk on, the temperature rises dramatically. Just 30 kilometers down, it's already hotter than the surface of an oven. But go deeper, into the mantle, and temperatures soar beyond 1,200 degrees Celsius. Here in this vast region of semi-solid rock, magma is born. A molten mixture of silicate minerals, volatile gases, and metallic elements like iron and magnesium. This magma doesn't just sit still, it moves, churns, and rises, driven by intense pressure and the Earth's internal heat. So what's inside this molten soup? Magma is rich in silica, and its exact chemical composition determines how explosive a volcano might be. High silica magma is sticky and traps gases easily, while low silica magma flows more freely. But trapped gases are what really matter here. Gases like water vapor, carbon dioxide, and sulfur dioxide are dissolved in magma under immense pressure, much like carbonation in a sealed soda bottle. And just like a shaken bottle ready to explode, the pressure must eventually find release. As magma slowly rises toward the Earth's surface, the pressure begins to drop. This allows those dissolved gases to expand rapidly, forming bubbles that push the magma even faster. If the magma finds a weak point in the crust, a fault line or a crack, it forces its way through. The pressure becomes too great, the surrounding rock fractures, and the result is an eruption. Some eruptions are gentle, allowing lava to ooze from the Earth's surface, forming new land as it cools. These are known as effusive eruptions and can be seen in places like Hawaii, where lava flows can last for months, even years. But others are anything but gentle. Explosive eruptions occur when thick gas-rich magma erupts violently, launching ash, gas, and rock high into the atmosphere. One of the most terrifying products of an explosive eruption is the pyroclastic flow. Imagine a boiling avalanche of ash and gas racing down a volcano's slope at over 100 kilometers per hour. It can be over 700 degrees Celsius, hot enough to vaporize anything in its path. Entire towns can be erased in minutes, as happened in Pompeii in 79 AD and at Mount Pelée in 1902. But volcanoes aren't just destructive, they're also creators. Much of our planet's land, including islands like Iceland and the Galapagos, was born from volcanic activity. Lava breaks down over time into rich, fertile soil. Volcanic ash replenishes nutrients, making nearby areas ideal for farming. And deep within the Earth, the heat from volcanic systems is tapped for geothermal energy, providing a clean and sustainable power source in countries like Iceland, Kenya, and the Philippines. Even our atmosphere owes some of its early composition to volcanic gases. Billions of years ago, as the Earth cooled, volcanic outgassing released water vapor and carbon dioxide into the air. A crucial step in forming oceans and enabling life. Today, scientists use a combination of tools to monitor volcanoes and try to predict when they might erupt. Seismometers detect tiny earthquakes caused by magma moving underground. GPS sensors and satellites track ground deformation, the bulging of a volcano's surface as magma rises. Gas sensors measure increasing emissions of sulfur dioxide, a telltale sign of unrest. But despite all this technology, volcanoes are still full of surprises. Their systems are complex, and even with warning signs, the exact timing and scale of an eruption often remain a mystery. Volcanoes remind us of the raw power beneath our feet. They can destroy, and yet they also build. They bury, and yet they create. Each eruption is a chapter in Earth's never-ending story of change. So the next time you see a volcano in the distance, quiet, unmoving, remember, it may be sleeping, but it is never truly still.